Great. So let's look at the queuing calculators and try and figure out how to analyze some of these questions that Carlo is interested in. Going to um, use the calculator, the GGK calculator. It's the most relevant here because we don't have the distribution of the service times. So we, we essentially just going to use a distribution. This model using the MMK would not be appropriate because we don't know that the service times are exponential. Um, I'm also going to try and model putting together this transcript. You have two submission items. One is the transcript, which basically what we're looking for there is anything that you do in your train of thought to develop your solution needs to be documented. It's going to be a little tedious, but hopefully we can get something out of this, and we're going to look at providing you with an auto grader to help that to assess that. And then you also have a report. So the transcript doesn't have a length requirement. It is a Word file, and just to cut and paste as you go. Maybe you'll have to type some things when you just think some, sort of critically think about the problem. And then there's a report, 4 pages. It's got some parameters. That's all inclusive, no cover page on, no cover sheet on that. And that's your figures, your references, your tables, all inclusive there. Okay, so let's try and analyze the base case. So in the queuing document, you've got this GGK calculator. And what I want to do is analyze the base case. So let's sketch it, and then I will run this, and I will cut and paste maybe just a screenshot of this thing as our evidence into the transcript, and then we'll move on to the next one. Okay, so in the base case, we're looking at the 10 baristas serving the they each serving 24 customers an hour. So let me just annotate this for you. I'm going to just sketch one of these baristas. The picture is identical for all of them, right? So there's 10 of these. And all we have to do is really analyze one. So the mean service time is 65 seconds, and the standard deviation, should maybe make that an S, is 20 seconds. All right, so cut to the chase here. We're going to populate. Lambda is 21, which is right at 24, excuse me. This is going to be 1. And the reason for that is, for a Poisson arrival process, which we do have here, the CV sub a squared is 1 because the standard deviation and the mean have the same value. So when you divide them, so this quantity here is of the inter-arrival times mean standard deviation divided by its mean, and square that. And so this is just 1 for Poisson processes. All right, so the service rate is going to be, I'm going to get it per hour. So there's 3,600 seconds in the hour divided by 65. And this one here, the CV sub a CV sub p squared, is going to be the standard deviation of the service time 20 divided by 65. I'm relying on this information here, and square that. And then in this base case, I have just one barista in the analysis because I'm just analyzing one in isolation. The overall cafe has 10 of these, but they're operating independently. They all have their own 24 per hour Poisson streams. So this is a 1. All right, so I'm going to pause here and just get all this done, and then I'll bring you back. Pause the recording, not the right, ran that for you. and get these results here. So notice that the utilization is low, 43.33%, and our average time a customer spends in the system is 0.0256. I've taken, populated a spreadsheet just so that I can annotate all these results, accumulate them, because you will have to likely build a table of some kind similar to this in your report to lay out different analysis. Likely what you're going to need is to demonstrate the marginal impact of all of these changes to Carlo, and then piece together some sort of composite plan where maybe multiple process innovations are affected. He'd want the numbers on that as well. So brief, what we've got here, 43 and a third percent utilization, and then the waiting time here is 1.536 minutes. I've also gone ahead and cut and paste this into my chain of thought transcript. So I did specify what my parameterization is. Maybe I should just add here. Don't want that. So stop my tracking here. Accept. Okay, just resolve it. Sorry. So with queuing calculator, let's take a moment and just cut and paste this and put it into a language model just to see if it can make it. This is just for interest sake. So I've got perplexity running here for a GG1 1Q. I have to specify K here to analyze this. Really want to make lambda 24. So what is it going to do here? So lambda equals 24. Okay, so yes. Okay, yes, give me utilization. 43 and a third percent. Now it's giving a fancy approximation here, which is fine. Which is 0.0256, very close, right? It's essentially what we got. Cool. Let's move on to the next one. So let's think about some of the innovations. The first one I want to plug in here, maybe I'm going to add a column, just insert. So I'll just click on this, insert a column to the right. What is the type here? So this is just, there's no type there, it's just the base case. So I'm going to do a utilization matters move here. And I'm going to look at just going to, let's say, 9 baristas. Yeah, sorry, now I want to make it 8. K equal to 8 baristas. So this is going to look much the same, but we do have to calculate a few things. So let's just put it in here and just think about what this looks like. So now they're still independent. There's just one fewer. Mu and CV sub p squared are going to look the same. CV sub a squared is going to be the same. They're going to see just slightly more intense arrival processes because now instead of having 10 baristas serving the 240 customers an hour, the customer count's not going to change because you're changing the baristas, right? But you will have 2 fewer baristas. So the 240 are going to be served by 8. So now they have to do 30 per hour. So that's the only change. I'll bring you back once I've made all those changes and populated. Right. For these results, essentially the only change here is the 30 for lambda. We're now up to 54.17% utilization with a waiting time in system of 0.0297. The reason I'm particularly harping on the utilization and the WS is because the utilization is an important metric for the EX, and it in fact ties into a note that I've written about the utilization and burnout. You need to protect the employees on both sides psychologically, not under or overutilize them. Take a look at the note. The waiting time in system is transferred in here. So I've gone ahead and I've populated my transcript again just to cut and paste. I did explain what I'm doing. I've considered reducing 10 baristas to 8. That's the only change. Lambda. And I also cleaned up that negative value here. So I think probably want to put a D in there as well. Okay, so I've got that populated right now, and then I also put this into my Google Sheet, and you can see, I haven't put it in yet, excuse me, 0.5417, and the time was 0.297. Let's move this one. 0.0297. And I want to just copy this one down here. So 1.782 minutes, fewer people serving you, makes sense. Let's move to the next one. I'm going to consider a pivot to the valves switch. So we'll go back to 10 baristas, switch. We're trying to analyze these things one at a time, switch clovers for valves. And this would be across the board. If you do a subset of the clovers, if you move them to valves, you would have a composite scenario that, in fact, you can only analyze using the simulation model. All right, so this one is a variance matters. Really, the standard deviation is the only thing that changes as you move here, going from 20 to 35. It is a semi-automatic machine. The clovers are automatic. So I'm going to copy this information here. I'm going to have to refigure the CV sub p squared now because that's changed. So you're back in that original setting where the baristas are operating independently. There's 10 of them. Only thing that's happened is pull the clovers, plug in the valves. So this guy here is now going to be, instead of 20 divided by 65, it's now 35 divided by 65 squared. So I want 0.28994 in my CV sub p squared, going back to that original. I'll come back when I got these results for you. Okay, so ran that for you. 24 on the lambda because we're back to the 10 baristas in the base case. And the only change on that is clovers to valves. So the revised CV sub p squared. Interestingly, your utilization remains the same as in the base case, 43.33%. And your W sub S is now changed because of the change in the variance. I went ahead and captured that here, and you can see it's a 1.62 minute, almost the same as in the base case. So now this is for an untrained, maybe I should just add in here untrained baristas. So what we can do is let's do the same thing, but just see what the win is. So now I'm doing two simultaneous changes, but let's see if the training makes a difference here. So this will be trained. So you might want to write up a little bit of language in your transcript, just explaining that, what we're doing here is, let's do that. Considering marginal changes. So considering marginal changes. I will save this, and hopefully when we've got the autograder ready, we can run this transcript through the autograder and just see what kind of feedback we get. Okay, so And I need to make a note here. Baristas are untrained. So I'm going to cut and paste this one down here. And it's be a quick fix to, let me bring you back when I got it to analyze this one. Got all that squared away. Here it is. Change this value here. It's 10 divided by 65 squared. Our utilization is the same as in the base case, 43 1/3. So notice how the variance piece does not change the utilization, but it does change the W sub S. So I've gone ahead and plugged that number in here, the 0.251. So just marginally better than the base case. You do have a lower standard deviation, but from a practical perspective, that is virtually identical. Okay, the next move is going to be to go back to the base case. So we have the clovers again, and 10 baristas, no training, just look at pooling. Okay, so now you're moving from that sort of independent piece to this. Just sketch it so we clear. So got a single arrival queue now. The artwork really suffers. So it's 240 per hour, and they join a single customer queue, but then you've got these 10 baristas. One's got a larger head than the other, but they're all doing a mean of 65 seconds and a standard deviation of 20 seconds, right? Because we're back in the base case setup. All right, so I'll bring you back when I got that set up, and we'll compare. Right, so I did pool the orders here. We've got that single stream of 240 per hour. The CV sub squared is back to what the base case looks like. We've got 10 servers now. No impact on the utilization here, but the W sub base has changed, and I've gone ahead and recorded that here. And you're now down about a half a minute relative to the base case. Quite a powerful move, but utilization is the same. All right, so, and I did go ahead and I documented that in my chain of thought. I'm going to, here is the cut and paste. I'm going to leave this clip here. What you do want to do is I guess I can't clear that now. You want to do a much richer set of scenarios than I've considered here. Make sure I'm recording. Yeah, I'm good. So like varying, barista numbers and looking at combinations of that with the valves, with or without training, with or without the pooling, to finally arrive at a solution. Remember, you've got psychology matters here as well. Ask yourself what you really need for the CX. Are these numbers acceptable? Maybe not, maybe yes. The psychology piece related to the baristas pooling, they would have to accept, possibly, don't know what the tipping practices are like there, but potentially accept a split tip pool. And there are also potential psychology matters moves. When I say psychology matters, I mean under that rubric where you lean on the history, you lean on the art, maybe both, maybe some other ideas, engagement ideas, to take folks' mind off of the wait time if you think that is an issue. Right. We will look at some composite scenarios when we hit the queuing model. But for now, this is what we got. We're still going to keep building on our transcript as we go through our queuing analysis, our simulation model analysis, and I'll see you there.